equation n equal to RA plus RB plus R divided by RB, right? Now if you substitute this RA value here, right? RA RB plus R, right? Now here if you substitute this in terms of RA here in this equation, if you substitute this equation 1 by substituting equation 1 in this equation 2, so therefore NRB is equal to R to n minus 1 divided by n plus 1 plus RB plus R, and if we simplify this equation, you will get this RB equal to R into 2n divided by n square minus 1. Okay, just listen. The RA equal to so in this equation 2, if you substitute this equation 1, you will get RB in terms of R into n. So this RB, we got it as RB equal to R into 2n by n square minus 1, right? So ఇది ఎలా వచ్చింది మనకి సింపుల్ గా. సో ఈ ఈక్వేషన్ లో RA వాల్యూ సబ్స్టిట్యూట్ చేసుకోండి. RA వాల్యూ ఎంత సబ్స్టిట్యూట్ చేసి సింప్లిఫై చేసామండి. ఓకే, సో నౌ we got this RA, that is shunt branch RA value, and series branch RA value and RB values we got in terms of terminating impedance, that is R and N value. Okay, now based on these derivations, now we'll see this, we'll design one symmetrical P attenuator. Okay, yeah, note down. Design a design a symmetrical T attenuator symmetrical T attenuator to operate between 75 ohms and U attenuation of 20 decibels, to the attenuation of 20 decibels attenuation. This is the given problem. Okay. Now we need to design one circuit, one attenuator circuit. That circuit should produce a attenuation of 20 decibels. Okay. So here attenuation it is denoted by alpha. Alpha equals 20 decibels. Okay. And terminating impedance. The terminating impedance it is given as, that is character that is given as R equal to R not equal to 75 ohms. These are the given data. Given kitchen data. Now we need to find out what should be the value of this R and RB. For what values of this RA and RB, this circuit is producing a attenuation of alpha is equal to 20 decibels. Right? Now, for this given data, now we will find out the N value, capital N value. So, if the attenuation is given in decibels, so we have an equation that is capital N equal to anti-logarithm of alpha by 20 if the attenuation is given in decibels. Similarly, if the attenuation is given in Nepers, simply capital N equal to anti-log alpha. Yes, is it clear? How to find out capital N value if the attenuation is given in decibels? So this is the equation, capital N equation. N equal to anti-log alpha by 20 if the attenuation is given in decibels. Similarly, if the attenuation is given in Nepers, this capital N is nothing but it is equal to anti-log alpha. If attenuation alpha is in Nepers. Okay, now from this given data, now we'll find out N equal to anti-log alpha by alpha. What is alpha? Alpha is given as 20. 20 divided by 20. Okay, that is nothing anti-log 1. Okay, now we find out this. What is the value of this anti-log 1? So this anti-log 1 is nothing but the 10. So therefore we got N equal to 10. Okay, so once we got that N value, then we can easily find out this RA and RB. Yeah, can anybody read out this RA equation? What is RA? RA value ఎంత వచ్చిందమ్మా? డిరైవ్ చేసాం కదా.
R into n minus 1 by n plus 1.
R into n minus 1 by n plus 1. So here is the equation. N value we got this as 10. So what about R? This R is nothing but terminating impedance, characteristic impedance for this attenuator. So it is given as 75 ohms. So therefore, substitute here 75 into 10 minus 1 by 10 plus 1. How much it is?
61.3.
Right, good. 61.3. Okay, similarly, 61.3 are the units ohms. What about RB? How will you find out RB? What is the equation for this RB? RB equal to
2n into R by n square minus 1.
R into 2n divided by n square minus 1. Good. 2n divided by n square minus 1. Again, substitute this. R value is 75 and 2 into 10 divided by n minus 1. ఎంత వచ్చిందమ్మా?
15.1515.
15.15. Okay, 15.151 ohms, right? So means 0.3 ohms, value is 61.3 ohms, and RB is 15.151 ohms, and the estimating impedance is 75 ohms, right? Okay. Now, if apply here some signal here, ఈ సర్క్యూట్ కి ఏదైనా సిగ్నల్ అప్లై చేస్తే మనం this circuit it will produce a attenuation of 20 decibels. ఈ సిగ్నల్ ని అప్లై చేసిన సిగ్నల్ ని సర్క్యూట్ will reduce to the value. With this attenuation we got this output signal here. Okay. Next, see one more formula. Next one. Yeah. An attenuator is required. Attenuator is required to introduce an attenuation of 30 decibels when connected between a source and load, each having an impedance of 600 ohms. Okay. Determine the values of series and shunt arms of the attenuator. Okay, clear? Chudamma, this is also a symmetrical T attenuator. So ఈ రెండు వాల్యూస్ ఫైండ్ అవుట్ చేయమంటుంది. అగైన్ series arm value and shunt arm value. Okay, the attenuator is required to produce an attenuation of 30 decibels. So output లో మనకి సిగ్నల్ 30 decibels తోటి attenuate అవ్వాలి. Means alpha value is given again in the decibels, right? And when it is connected between the source and load, attenuation of alpha of 30 dB, and when it is connected between the source and load, having an impedance of 600 ohms. This is source అంటే input, this is called as source. In between source and load, ఈ రెండింటి మధ్య ఇక్కడ ఇంపిడెన్స్ ఇది 600 ohms ఉంటుంది. అంటే capital R value, characteristic impedance, it is given as 600 ohms, and alpha value it is given as 30 decibels. So we find out this RA and RB again. Okay, so again here in this problem also attenuation it is given decibels. Okay. So to find out this capital N, so if the alpha is given in decibels, so we have one formula, capital N equal to anti-log alpha by 20. Okay, so therefore anti-log alpha it is given as 30 by 20, that is nothing but the anti-log of 1.5. Okay. So anti-log 1.5, it is nothing but anti-log 1.5 is nothing but the 31.6. The calculus cheyandam, those who are having the calculus, we find this value. So therefore capital N we got it as 31.6. Yeah. Then next, now we find out this RA and RB. Okay, what is RA? RA is n minus 1 n plus 1. RB equal to R into 2n divided by n square minus 1. Straight substitutions. So R value తెలుసు మనకి, n value తెలుసు. Substitute చేయండి. You find out this R value and RB value. That's it. Calculate how much you got R and RB values. Ajay? Ajay?
Yes, sir.
Yeah, please note down the attendance now.
Yes, sir.
Who is the absentee? Note down the absentee numbers.
Okay, sir.
ఎంత వచ్చిందమ్మా వాల్యూ, ఆర్ఏ వాల్యూ? చేస్తున్నారా ఎవరైనా? ఎనీబడి ఈస్ డూయింగ్?
563.19 వచ్చింది సార్.
Right, good. RA is 63.2 ohms. Good. Next, similarly find out RB value.
Sir, alpha value ante
Alpha is nothing but the attenuation.
anti-log of 30.
Okay, if alpha value is given in decibels, so only find out capital anti-log alpha by 20. Attenuation అనేది dBs ఇస్తే ఈ ఫార్ములా యూజ్ చేయాలి. క్యాపిటల్ ఈక్వల్ టు యాంటీలాగ్ ఆల్ఫా బై 20. ఓకే, డెసిబల్స్లో కాకుండా నేపర్స్లో ఇస్తే క్యాపిటల్ ఈక్వల్ టు యాంటీలాగ్ ఆల్ఫా. క్లియర్?
Yes, sir.
రైట్.
Yes, sir. Attendance noted.
నోటెడ్. ఓకే, అది నాకు వాట్సాప్ సెండ్ అది.
Okay, sir. Send yes.